All right, so here's the video for notes 5-5, which is conditional probability. So for this example, it says students at the University of New Harmony received 10,000 course grades last semester. The table below breaks down these grades by which school the university taught the course. The schools are liberal arts, engineering and physical sciences, and health and human services. So this is called a two-way table because it has two different variables. We're looking at the grade that they got. So these are all the A's, the B's, and the people who got below a B. And these are each of the schools in the university. So first thing we need to do is we need to figure out the total for each one. So if we go across, if we add the total number of individuals in liberal arts, so we add up all of these grades, that would be 6,300. The total across for engineering and physical sciences, so we add together the next row, we would get 1,600. And then if we add together the health and human sciences, we have 2,100. Oops, too many zeros. So that total accounts for the 10,000 course grades in the previous semester. But we can also add together the columns. So adding up all the A's, that's 3,392. So in total, there were 3,392 A's given out. If we add all the B's, there's 2,952 B's. And then the number of individuals who got below B would be 3,656. And if we add these across this way, those would equal 10,000. So we're kind of looking at two things. We're looking at the breakdown according to the course and the breakdown according to the grades. So now that we have this table with the totals, now we can find the probability of certain events. So it says, consider the two events we're naming X, which means the grade comes from an EPS course, and Y, the grade is below a B. So first question is, what is the probability of X, meaning the probability that the grade comes from the EPS course? Well, in here we see that there's a total of 1,600 total grades from the EPS, so that's 1,600. And remember, in total, there's 10,000 total grades. So the probability that it comes from an EPS course would be 1,600 divided by 10,000, which is going to be 0.16. Or we can think of 16% of the grades came from an EPS course. Now looking at the second question, says what is the probability of Y? So Y is the grade is below a B. So below a B would be this last column. So this is the number of grades below a B. So 3,656. And then remember, again, there's 10,000 total grades in the class. So that probability, we're going to do 3,656 divided by 10,000. That would be 0.3656. All right, next question, it says, what is the probability of X or Y, meaning EPS or the grade is below a B? So that's going to be probability that it's EPS plus the probability below a B minus the overlap, which is the probability that it's EPS and below a B. Well, let's see. The number of EPS is going to be 1,600, and we know that these are all going to be out of 10,000. The number below a B was the 3,656. And then we have to subtract the overlap. So if we look, the overlap, so here's below the B, here's the EPS. So the overlap, the stuff that we're counting twice, is going to be that 800. So this 800 here was counted for both. So that's going to be the overlap. So 800 over 10,000. So for this one, since they all have the same denominator, we can just do the numerator. So 1,600 plus 3,656 minus 800. So that's going to be 4,456 over 10,000, which is 0.4456. The last one, what is the probability of X and Y? Well, this is actually what we just calculated here. That's a probability that someone is from the EPS school and has below a B. So that's going to be 800 over 10,000. which is going to be 0.08. All right, so the next set of questions, it says, if we know that the grade came from a liberal arts course, what is the probability that the grade is an A? So this statement saying that we know that the grade came from a liberal arts course, which means the only row that we're looking at is this first row. So we know it came from a liberal arts course. We want to know what is the probability that the grade is an A. Well, looking at that row, the A grades would be this right here. So that probability would be 2142 over 6300. Since we know that we're only looking at liberal arts, that's the probability. So we basically want to know what proportion of grades in the liberal arts school were A's. So that's going to be 0.34. All right, the next one says, what is the probability that the grade is below a B given the information that it comes from an EPS school? So in this particular example, we know that it's from the EPS school, meaning we're only looking at this column right here. So for this particular example, we don't care about liberal arts. We don't care about health and human sciences. We want to know what is the probability that the grade is below a B. Well, if we look here, below a B would be the 800. So it's going to be the 800 out of the 1600 total. So 800 divided by 1600. Well, that's going to be 0.5. So the other way we can think about this is 50% of the grades from EPS were below a B. So these two particular examples, if you notice, to contrast the previous ones, in the previous examples, our denominators were all 10,000. Because in those previous examples, we were looking at all the schools together. But in these particular examples, we were given some information. We knew that the grade came from a liberal arts course, which means that we were only looking at that top row. And then in number 6, we were given the information that it came from the EPS school, which means we were only looking at the second column. So this is called conditional probability. Conditional probability is when you're calculating something when you're given some information. All right, so let's take a look at another example. So in looking at this table, it's a little bit different because these numbers here, instead of being counts, like the number of people who have a bachelor's degree, number of people who have a master's degree, it's already a probability, meaning 0.41 of people are female and have a bachelor's degree. So these are already calculated as proportions versus the previous example, we had to get the totals for the count. So in this case, we don't actually need the totals of each row and each column. We should just be able to answer these questions by adding together or subtracting these probabilities. So number 1 says, what is the probability that the individual is female? So female, we're looking at this first column. So that means we're going to add up the whole top row. So that's going to be 0.41 plus 0.14 plus 0.02 plus 0.01, which is 0.58. So the probability that the individual is female is 0.58. Number 2 says, if you know the individual has a professional degree, what is the probability that the individual is female? So this is a case where we know some information. So we know they have a professional degree, which means we're only looking at this column. We want to know what is the probability that the individual is female. So in that column, the amount of females is 0.02. So that probability, we want to know what proportion of people in professional degrees are female. Well, we need the total for professional degree, that's 0.04. So that's going to be 0.02 divided by 0.04, which is going to be 0.5, 50%, which we can see here, right? This is split into 2 evenly, so that's why it's 50%. 0.02 divided by 0.04 is 0.5. Number 3 says, what is the probability that the individual has a master's degree given that the individual is male? So master's degree, let me use a different color here. So master's degree would be looking at, the given information is that they're male, which means we're only going to be looking at this row. And in that row, those people who have a master's degree is going to be the 0.10. So the probability that they have a master's degree given that they're male, we need to figure out the total proportion of males. Well, if the proportion of females is 0.58, that means the proportion of males is going to be 0.42. So the proportion of males who have a master's degree is going to be 0.10 divided by 0.42. So that is 0.238. Okay, number 4 says, what is the probability that the individual is either female or has a professional degree? So this is an or, so we're going to do probability that they're female plus the probability that they have a professional degree minus the overlap, which is female and professional degree. Well, we know that female is 0.58, professional degree is 0.04, and the amount that we are double counting is this 0.02. Oops, sorry, not that 0.02, this 0.02, because that's the female and professional. So this is going to be 0.60. All right, lastly, probability that the individual is either male or has a master's degree. So male plus master's minus male and master's, the overlap. So the probability of male is 0.42. Probability of masters is 0.24. That's adding together these two. And then we have to subtract what we double counted. So we double counted male and masters, which is the 0.10. So that's going to be 0.56. Okay, so now that we looked at a couple different examples of applications of conditional probability with two-way tables, let's now formalize a definition of conditional probability. So conditional probability is a probability we assign to an event that can change if we know if some other event has occurred. So the probability of an event can change if we know that some other event has occurred. So if we look at this, it says the conditional probability of A given B is probability of A and B on top divided by the probability of B. So the sample space changes because you know B happened for sure. So just to give you kind of a concrete example, right? If I tell you, oh, what is the probability of picking this is going to be a bad example because this is an independent example, but what is the probability of picking an ace from a deck of cards? Well, from a deck of cards, we know that that is 4 out of 52. Okay, but what if instead I told you that the card that I'm holding is red, right? So if I asked you what is the probability of picking an ace given that you know it's red? Well, if we know that it's red, we're only looking at 26 total cards, right? And of those 26 total cards, there are only 2 aces. So that probability would be 2 out of 26. So notice these probabilities are the same. That's just because when it is independent, these probabilities should be equal. But as we can see here, we kind of show that the sample space changes. We're no longer looking at all 52 cards, we're only looking at the 26. And in the numerator, these are the cards that are both red and aces. The denominator is only the cards that are red. To apply this to what we just looked at, when we looked at those examples, from the first example, we were talking about the grades from the different courses. When we found the probability that the grade is below a B, given that it came from an EPS school, we were no longer dividing by 10,000, we were only dividing by the total number in the EPS school, which is 1,600. And then in the numerator were the individuals who got below a B and who happened to be in the EPS course. Okay, so let's just take a look at an example from the practice test where this is just applying the formula. So an event A will occur with probability 0.7, event B will occur with probability 0.3, and the probability that both A and B occurs is 0.2. We want to know what is the conditional probability of A given B. So we're trying to find the probability of A given B. Well, that probability is just the probability of A and B based off the definition over whatever's given. So in this case, we're given B. We know that B has happened. So looking at the information they give us, we have the probability of A and B, that's 0.2. And we have the probability of B, which is 0.3. So if we looked at a Venn diagram of the situation, this is kind of what it looks like. So it says probability of A is 0.07. So this circle in total has 0.07. 0.5 of it is just A, 0.2 of it is A and B together, which adds up to 0.7. And then if we look here in this circle, we have probability of B, which is in total 0.3, but we know that 0.2 of that is A and B. So if we want to find the conditional probability of A given B, we know that we're only looking at this circle here, right? So that's why our denominator is 0.3. And inside of that circle, the probability of A that's happening inside that circle is 0.2. So 0.2 over 0.3, which is going to be 0.67. So A is going to be the correct answer here. All right, so let's take a look at another example. So it says, in an apartment complex, 40% of residents read USA Today, only 25% read the New York Times, and 5% read both papers. What is the probability that a randomly selected resident reads the New York Times, given that they also read USA Today? So we're trying to find the probability that they read the New York Times, given that they read USA Today. Well, using our probability rule, we know that this is the probability that they read the New York Times and USA Today over the probability that they read USA Today. Well, we have these probabilities. The probability that they read both is 0.5 or 0.05. And the probability that they read USA Today is 0.4. So if we're talking a Venn diagram, we can make a Venn diagram like we did in the previous. So we know that the shared is 0.05. 40% read USA Today. So 40%, that would mean 35% would go here. All right, let me stick to decimals. So 0.35. And then for the New York Times, we know 25% read, but we know that 5% of that is shared, so that means it's going to be 0.20. So if we want to know the conditional probability that a randomly selected resident reads the New York Times, given that they also read USA Today, so we're given that they are reading USA Today, so that 0.05 is the proportion of individuals that read the New York Times, and that 0.40 is these two added together, the total that reads USA Today. So that's going to be 0.125. Okay, so this one, it says video sharing sites like YouTube are popular destinations on the internet. About 27% of adult internet users are 18 and under here. 45% are 30 to 49, and the remaining 28% are 50 and over. The Pew Internet and American Life Project finds that 70% of internet users age 18 to 29 have visited video sharing sites, which means 0.3 have not. It says that 51% of ages 30 to 49 have visited video sharing sites, which means 0.49 have not. And lastly, 26% of those 50 or older have visited video sharing sites, which means that 0.74 have not. So here's a tree diagram that represents that situation. So to find these probabilities here for the blue line, we just use the complement rule because we know that you either have visited a video sharing site or you haven't, so those probabilities should equal to 1. So now let's answer some questions. It says select an adult user at random, find the probability that this person has visited a video sharing site. So there's kind of 3 cases here where they have visited a video sharing site. That would be this first case, this third case, and this 5th case here. And we want to add up all of those probabilities together. Remember, this is a tree diagram, so we're using the multiplication rule. So the first probability, we're going to multiply 0.27 times 0.7. And then we're going to add that to the second case where they're 30 to 49 and they visited a video sharing site. So that's going to be 0.45 times 0.51. And then the third case, the 50 and older, that's 0.28 times 0.26. So So that probability is 0.9585. Okay. Part B says, given that this person has visited a video sharing site, so we're only looking at these cases here. Find the probability that he or she is aged 18 to 29. So we want to know what is the probability that they are 18 to 29 given that they visited a video sharing site. So using our probability rule, we can write it this way. So they're 18 to 29 given that they visited. So that's going to be the probability that they're 18 to 29 and they visited over the probability that they visited the site. Well, we know the probability that they visited a site is what we calculated in the previous example. So that's going to be 0.9585 on the bottom. And in the numerator, we want just the probability that they visited the site. Well, that's just going to be that, and that they're 18 to 29. So that's going to be 0.27 times 0.7. So it's going to be 0.27 times 0.7. And then we're going to divide that by, so that's going to be 0.189 divided by 0.9585. So that's going to be 0.197. So the probability that the person has visited, or that they're 18 to 29 given that they visited a video sharing site, is 0.197.